So for this question, it's asking us to calculate enthalpy change and change in entropy for this reaction, and then decide in which direction each of these factors are going to drive the reaction, and then use the values to predict whether this reaction is spontaneous at 25 degrees Celsius. So if we start with calculating delta H, it's the sum of our products minus our reactants. So we already know N2 and H2 are going to cancel out because it's going to be multiplied by 0. So we don't have to worry about that. So it's pretty much just going to be 2 times for this. So 2 times negative 46.11, which is going to be about negative 92.22 kilojoules. And because this is negative, we know that it's going to probably drive our reaction forward. And then if we calculate our entropy change, which is going to be delta S, we just do the same thing. We do the sum of entropy of our products minus our reactants. If we start with ammonia, just to keep it regular, we do 2 times 192.45, which is going to equal 384.9. Then for our reactants, we're going to just do 1 times 191, and then 1 times 191, just going to be 191.61, plus 3 times 130.68. And if we add all of this up together, we'll get 583.65. So then delta S is going to be 384.9 minus 583.65, which then equals negative 198.75. And so again, this is a negative value, which makes sense because we go from our 4 gas molecules down to 2. And then if we want to figure out if the reaction is spontaneous at 25 degrees Celsius, we're going to use our Gibbs free energy equation. So delta G equals delta H minus E delta S. But before we plug everything in, we're gonna have to need to check our units. So delta H is in kilojoules and delta S is in joules. So we're gonna have to convert our entropy to kilojoules, which is going to give us 0.19875, don't forget negative, kilojoules. And so then we'll be able to plug everything in. So delta G equals negative 92.22 minus 298, it's just going to be our basic Kelvin, minus 0.19875. And then that is going to give us delta G of negative 32.97 kilojoules. And since delta G is going to be negative, it's going to tell us that the reaction is spontaneous. So our negative entropy is going to drive our reaction forward, and then the negative delta S is going to try to resist that, but the energy that's being released by the reaction is actually going to be strong enough to overcome our decrease in entropy. And so the reaction is going to be spontaneous at 25 degrees Celsius.